Alright, so let us continue from what we did earlier on, and this time around we'll talk about the second type of partial fractions that we have, going from the denominators. This time around we'll be dealing with the factorizable denominators. It's very similar to what we did earlier on, so this is just the follow-up to that. Right, so what does this tell us? It says, this question says, resolve 2x squared minus 3x minus 10 over x plus 2 x squared minus 9 into partial fractions. So of course this time around we have a quadratic expression in the denominator, which is x squared minus 9, and now this x squared minus 9 is actually factorizable. You are able to recognize that this is a difference of two squares problem. You can represent x squared minus 9 as x squared minus 3 squared, which is factorizable, right? So but let's write our problem well and see how we can easily solve this problem. We have what? 2x squared minus 3x minus 10 over, what do we have? X plus 2 x squared minus 9 is going to be the same thing as 2x squared minus 3x minus 10 over x plus 2, as this is the same thing as x squared minus 3 squared, which will become x plus 3 x minus 3, a difference of two squares problem. So in this case we just have the same exact type we worked earlier on, like these cases that we have, right? So that's what we have here, but this time around we have three denominators. We have x plus 2, x plus 3, and x minus 3. So let's work with that. So our problem translates to 2x squared minus 3x minus 10 over, and we have x plus 2, x minus 3, x plus 3, and x minus 3. So it will become what? A over x plus 2 plus b over x plus 3 plus c over x minus 3. So that's what we are going to have when we have something like this. So what does that give us? That means that by the time we try to solve our fraction, our LCM is going to be what? X plus 2, x plus 3, and x minus 3. So we take this entire thing, cut it by x plus 2, we are left with a, open bracket, this 2. So that's going to be x plus 3 x minus 3. Then we have b. So for b, this will cut this and we are left with this 2. So that's going to be b, open bracket, x plus 2 x minus 3. Okay, so let me zoom a little closer to the work that we are doing. Alright, then we have for c now. So for c, this will cut this and we have plus c. C will be what? X plus 2 x plus 3. Remember, c as well is also under this fraction. That's going to be x plus 2 x plus 3 and x minus 3. Try to ensure everything stays 1, so that as 1, so that you don't confuse yourself. I didn't allocate proper space in my own work, so everything here is equal to this fraction that we have here. So that's going to be 2x squared minus 3x minus 10 over, what do we have here? X plus 2 x plus 3 and x minus 3. So that's it. So in usual fashion we just work with the numerator, and the numerator tells us what? 2x squared minus 3x minus 10 equals to what? A, open bracket, x plus 3 x minus 3, then plus b, open bracket, x plus 2 x minus 3, as you can see up here, then plus c, open bracket, x plus 2 x plus 3, as you can see here as well. So now the next step we are going to do is to ensure that we expand these brackets. So when we expand this, we can have an expression that we will work with. So what do we have on the left hand side? So we have 2x squared minus 3x minus 10 equals to, so for a, I don't need to think too much. X plus 3 x minus 3 is just the difference of two square, so it should give me x squared minus 9 again, so plus b. Now I will need to expand x plus 2, x plus 3, so x minus 3. So let me expand that quickly at the back here. So where do I have a free space? Okay, used everywhere. So here we have x plus 2, x minus 3. Hopefully that's what we have. Yes, x minus 3. So we have x, I have x minus 3, then plus 2, x minus 3. So that becomes x squared minus 3x plus 2x minus 6. So that is x squared minus x minus 6. So our b will become x squared minus x minus 6 for that. Then we have for c is going to be what? So it's just x plus 2, x plus 3. So let's try to change this one to plus here so we don't do it over again. Okay, so sorry for the technical break. As I was expanding, we had alright, so as I was expanding, we have plus, plus, so we don't have to do it all over again. X times x is x squared, x times 3 is plus 3x, 2 times x is, and 2, this is plus, so this is plus 5x plus 6 for that one. So this is going to give us x squared plus 5x plus 6 here. So alright, so let's solve it completely now. So we have 2x squared minus 3x minus 10 equals to, let's open in brackets, we have ax squared minus 9a plus bx squared minus bx minus 6b plus cx squared plus 5cx plus 6c. So of course this is the method in which I'm going to be comparing the coefficients. Here we have the x squared term, the x term, and the constant term here. So I'll be bringing all three of them together. So let's start what we can do. Let us try to arrange this our right hand side first. So we have 2x squared. So we had 2x squared minus 3x minus 10. Hopefully that's what we have on the left hand side. Yeah, and here we have ax squared minus 9a. Let me just repeat what we have there. Ax squared minus 9a plus what? And we have bx squared minus bx minus 6b. So we have plus bx squared minus bx plus 6b. Okay, minus 6b, not say plus, minus 6b. Then we have cx squared plus 5cx plus 6c. So we have plus cx squared plus 5cx plus 6c. Alright, so that's what we have here. So what we are going to do is that we're going to arrange them together. Everything that contains x squared, everything that contains x, and everything that is a constant. So let's work with it. So on the left hand side we have 2x squared minus 3x minus 10 equals to, let's arrange what we have here. So we have the x squared term to be a, b, and c. So that's going to be a plus b plus c. They all have x squared in them, right? Then plus, what do we have? The terms that have x. So we have minus b and 5c. That's minus b plus 5c. Those have x. So plus, let's take the constants now. We have minus 9a minus 6b and 6c. So that's minus 9a minus 6b plus 6c. Right, so let's ensure we count so as to avoid no confusion. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 terms here. So here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 terms here. So that's everything is correct here. So what does this mean? It means that when we add ab plus c here, it's to give us these two here, because those are the ones that have x squared. And we have minus b plus 5c, which have x here, to give us minus 3. And here we have this as well, to give us minus 10. And those are the three equations we'll be working with. So let's carry on with it. So it means that a plus b plus c must be equals to 2. Let's call it our equation 1. Then we have minus b plus 5c. Like this is going to give us what? minus 3 from here. That's going to be equation 2. Then the third way, we have minus 9a minus 6b plus 6c is going to give us what? Minus 10. That will become equation 3. All right, good. So this is very interesting now, and this is one of those things you are still new in your further mathematics journey, right? So we're having 3 equations, or in terms of a, b, and c. Now the normal equations we know, the simultaneous equation we know, they used to have 2 unknowns, maybe x and y, b and c, a and b, and something like that. But this time around, we have simultaneous equation of 3 unknowns. And in order for us to have 3 unknowns normally, we are supposed to have 3 equations like that so that we could solve. And luckily for us, we have 3 equations. But your equation number 2 does not have a term here. And so I could have easily just worked the solution to this by using a calculator. But because this particular problem is very, very common in partial fractions, I want us to go through the step of understanding how to solve this. And this is the technique we would use. Alright, so this is the technique we would use for this. We would try to take an equation from from the 3 equations. We'll work with 2 equations. Those 2 equations must contain only 2 terms. For example, now only the same 2 terms rather. So if you work for equation 1, we have a and b, and we have equation 2, we have what? A and b as well. That's the idea I want to use. And how am I going to achieve that? Because my equation 1 and equation 3 both carry the c term here, the c term here, and the c term here. I can go to equation 2, for example, and try to get me my b term in terms of c. But after substituting for here, I'm going to have my equation 1 and equation 2 in terms of a and b alone, and that's what I am going to do here. So we say from equation 2, equation 2 tells me that minus b plus 5c equals to minus 3. Oh, okay. I want my b to stay alone, because if I try to work with c, I'll be having a fraction because I have to divide by 5. So what do I do? Let me take minus b to this side and take minus 3 to this side. So we have 5c plus 3 is equals to b, which is also the same as b is equals to 5c plus 3. Let me call that equation 4. So what I will do is that now that I've gotten an equation for b, I'll substitute it in equation 1 and equation 3. Equation 1 and equation 3. I'll say substitute b equals to 5c plus 3 in equation 1 and 3. So in equation 1, I have what? Right, so in equation 1, I had a plus b plus c equals to 2. So it's going to become what? A plus b is 5c plus 3. So that's going to be 5c plus 3 plus c equals to 2. So this is b, 5c plus 3 then plus c equals to 2. So what does our equation become? We have a plus 5c plus c is going to give me 6c. And by the time I take 3 to the other side, it becomes 2 minus 3, which is now equal to minus 1. That will become equation 5, because equation 4 from here. Now, I did that to equation 1 and it became this. So I'll do the same thing to equation 3. Equation 3 tells me that minus 9a minus 6b plus 6c equals to minus 10. So what do? I'll say what? Minus 9a, remember I'm substituting b, which is 5c plus 3, that's minus c, 6, open brackets, 5c plus 3 plus 6c equals to minus 10. So what do I have? I have minus 9a, minus 6 times 5c is minus 30c, minus 6 times plus 3 is minus 18, then plus 6c equals to minus 10. So let me put things alike. I have minus 9a. Now, minus 30c plus 6c will give me minus 24c, which is now going to be what? If I take minus 18 to the other side, I have minus 10 plus 18. So that becomes minus 9a minus 24c equals to minus 10 plus 18 will give me 8. So that becomes my equation 6. So now that I've been able to reduce my equation 1 and equation 3 to two equations that contain the same two terms, in this case a and c alone, a and c, I will have to solve equation 5 and equation 6 using the simultaneous equation. So I will say what? Solve 5 and 6 simultaneously. So when I solve 5 and 6, from equation 5, I have a plus 6c equals to minus 1. And from here, I have minus 9a minus 24c equals to 8. So this is my equation 5, and this is equation 6. Now, if I want to make equation 6 to have the same coefficient for c, what do I have to do? I can realize that, if I multiply equation 5 by 4, I will have the 24 that this one has. I don't have to multiply by 24 then by 6. That will give me two big numbers. So if I multiply by 4 and multiply by 1, 6 times 4 will give us 24c. So that works as well. So this is going to give me 4a plus 24c equals to minus 4. And here I have minus 9a minus 24c equals to 8. So now I have the equations like that. So I need to solve for a by eliminating c. What do? The signs are different, so I add 4a plus minus 9a. Plus times minus is minus. 4a minus 9a is minus 5a. 24 plus minus 24c is 0, and that is minus 4 plus 8 is minus is actually 4, not minus 4. So divide both sides by minus 5 over minus 5, cut, my a is equals to minus 4 over 5. So now that we've gotten a, we can get c from this equation 5 or 6. Then when we get c, we can now eventually go and get b as well. So we've gotten a to be minus 4 over 5. Let us substitute in equation 5 to get our c. So we can say substitute a is equals to minus 4 over 5 in equation 5. So what does equation 5 tell us now? So equation 5 tells us that we have a plus 6c equals to minus 1. So we have a plus 6c equals to minus 1. So we have minus 4 over 5 plus 6c equals to minus 1. Take this to the other side and we have 6c equals to minus 1 plus 4 over 5. We have that 6c equals to, now when we have minus 1 plus 4 over 5 minus 1 plus 4 over 5 gives us minus 1 over 5 minus 1 over 5. By the time you cross multiply, I have that minus 1 is equals to 30c. Divided by 30 divided by 30, and I've got my answer that c is equals to minus 1 over 30 as well. So I've gotten a, which is minus 4 over 5, and I've gotten c, which is minus 1 over 30. So I can now work and recollect that, from my equation 4, I got that b is equals to 5c plus 3, and I can use it to solve that. So I will say, okay, from equation 4, b is equals to 5c plus 3. So that's going to be 5 times minus 1 over 30, then plus 3. 5 here 1, 5 here 6, which is minus 1 over 6 plus 3. And that's going to be what? Minus 1 over 6 minus 1 over 6, then plus 3 will give me 17 over 6. So that's what? 17 over 6. So now we've gotten a, we've gotten b, and we've gotten c successfully. It took us a long time and with a lot of things to do, but we finally got there. So we got a. So we got a to be minus 4 over 5. We got b to be 17 over 6. And we got c to be minus 1 over 30. Now, please remember that this is not even the the answer to the question, because you need to substitute it to the mock-up fractions that we did over here. So our answer, which says 2x squared minus 3x minus 10. So we have that our partial fraction, which is 2x squared minus 3x minus 10 over, what do we have? X plus 2x plus 3x minus 3, x plus 2, x plus 3, x minus 3 is going to be minus 4 over 5 open bracket x plus 2 plus 17 over 6 open bracket x plus 3 plus minus 1 over 30 open bracket x minus 3. Now, because this plus and minus will multiply, we can see our answer is becoming minus 4 over 5 open bracket x plus 2 plus 17 over 6 open bracket x plus 3 minus 1 over 30 x minus 3. And that is the answer to the problem. It took a long time and it took a lot of solvings. There is an easier way to solve this, but I intentionally took this long way so as to serve as a little bit of a preamble of what is to come, right? So if you look at it here now, remember I gave you two methods for solving partial fractions, for resolving partial fractions. Now the actual first method to do, which is by taking, if you work from here, we take x is equals to minus 2, take x is equals to 3, x equals to minus 3. In all those cases, we are going to solve our answer easily and quickly. Well, I intentionally went through this entire step because as we move on, this is what we are going to be doing for our problem, which is a much more complex scenario where we'll be having these equations. In this case, we had 3. In some cases, we have 4. And even in some extreme cases, we have 5. So in those cases, we need to actually learn and go over solving them again properly, like that. So that's why I had to take this first example to show you how things are being done, so that you get prepared and well armed for what is to come. So what the exercise for you to do is this, is that I want you to solve this problem that we did now. After resolving it to this simple linear expressions here now, I want you to resolve it not using this method that I've already done, but to go and use the initial first method that I taught you to solve with, which is to say, when, like in this case now, when x plus 1 is equal, you say x plus 1 equals 0 and you put x is equals to minus 1. So in that case, you see that you wouldn't even take a long of solutions, talk less of solving for 4 pages to get your answer. That's what I'm expecting you to do right now. So when you've done, watch this video again to understand everything that is done properly, and then solve this question with the first method, and let us see.